I want us to discuss the basic understanding of how we do science. How did science originate? What brought us to the moment of applying science in a way that we can ask very complicated but very meaningful questions about the history of life, evolutionary biology, and how the Earth came to be. So to do that, let's encapsulate that in a discourse about the nature of science. What does science provide for us, and how did science come to be? Now, again, this is not a philosophy course. There are courses that will go into great detail about this, but a short encapsulation, I believe, is very important for us to understand how we use the basic concepts throughout the class. So one of the things that I think we should start with is the idea of critical free thought. Now, there's many parts of our society that critical free thought thrives, and it's actually the underpinning. There's other parts of our society that does everything possible to stop critical free thought. And this is not a new thing. Actually, society used to squash and try to destroy all forms of critical free thought. So let's start with society several thousand years ago, and then we're going to come up to the modern day. So one of the great heroes of scientific endeavor is Socrates. And Socrates lived from about 470 BC to 399 BC. And he lived in a time period in ancient Greece where society was very hierarchical. And that's truly what Socrates did for us. Socrates brought the idea, I describe it as society at that time in many ways was kind of a dark void within a large balloon, and Socrates came and brought a pinhole, pricked the balloon, and brought a small pinhole of light into a dark morass. And that dark morass was that society would tell people what to do, and that was the end of the story because it was truth. Socrates brought to the table the idea that, well, let's employ critical free thought. Let's use our mind, let's use our reason, let's use our senses, and let's discuss this. And that discussion process of using those techniques and then having an open, free discourse, he called that the dialectical method. And that Socratic dialectical method is the idea that you freely, critically evaluate and challenge, and you even go to one more step where the instructor or the professor or the politician or whoever is guiding the discussion takes the attitude of a devil's advocate. In other words, taking a stance that that person may or may not believe in, but using it as a leveraging tool to draw out from the participants what they really think and what their evidence is for that. So the Socratic method was critical. But what's, I think, especially sobering is that the Socratic method was the step forward towards accuracy and truth, but it was also the death sentence for Socrates, because eventually society responded very negatively to this. And society not only was unhappy, but they put Socrates to death. They put him in prison, and they forced him to drink hemlock. Now, Aristotle ended up being one of the first true paleontologists who thought about evolutionary biology. Now, it wasn't couched in those terms, but Aristotle did a lot of hiking in the mountains throughout Greece, and when he was high up in the mountains, he thought about and wrote about the idea that he saw fossils in rock that were lifted out of the ocean, and he saw those fossils lived in the marine environment. And he deduced from that that those rocks must have formed in the ocean and then been uplifted by some kind of force. He also saw that in those rocks, the fossils that are at the base of the rock, corals and brachiopods and clams and snails, they changed from the bottom of the rock to the top of the rock. And he further deduced that there must be a history of evolutionary biology change. Again, he didn't use these words, but he observed that. So our first true paleontologist, evolutionary biologist was Aristotle. And then we've had a little bit of time in human history to move forward from that. Now, some of the questions that Aristotle would want us to bring to the table for studying evolutionary biology are things like, what is your main point? Can you give me a good example of what you're talking about? Can you summarize for me what you just discussed? What are you assuming? What kinds of ideas do you know but not know? And then what are you assuming might be possible to support your assumption? What evidence do you have? That's always a good one, right? What real evidence do you have versus some kind of an emotional knee-jerk response to something you feel strongly about? We as humans are always trying to decipher those things and really calling out true cold and hard, fast evidence from emotion or from assumption is really, really good. And then other things like what can you generalize from this, and how can you make predictions, because fundamentally science has to be reproducible and predictable. And if it doesn't fulfill both those, then it's really not rigorous or useful science. Later on in history, people took these ideas and they changed the wording a bit. And the wording's a little bit complicated, but it's important, I think, to put on the table right now. The phrase is analogy identifies anomaly. So the concept of analogy is that we as humans have an experiential base that we bring to anything that we are part of. And if we see something new, the first thing we do is compare it to something else we've seen or experienced. So that's the analogy. Now, in that experience, if we see something that if through analogy, from our experiences, we see something that doesn't fit, it's something new, it's something unexplained, then it's something that rises as something that's maybe concerning or startling or interesting, and something that should be identified as a topic of further investigation. So that's anomaly. So analogy identifies anomaly is a really important toolkit we have. The next person we want to look at, and again, this is a whirlwind tour, there's many others we could bring into play, but it's René Descartes, and he lived in 1596 to 1650 in France. He was a true Renaissance man, philosopher, mathematician, writer, but he wrote a book in 1637 on the Discourse on the Method. And in other words, what Descartes did was to bring the concepts of Socrates to the next level and say, if we have critical free thought and we use our multiple senses and everything that we do in our everyday life, then we can acquire knowledge and have a genuine foundation of what's going on. But it also, it's encapsulated in this great statement of, I think, therefore I am. And so he gave an example called the wax model, and I think that kind of explains where Descartes was bringing us. The wax model is the following. If you have a candle that's cool with a wick in the middle, let's say that some candle maker just made it, and you set the candle in a candle holder in front of you on the table and you describe it. You say, oh, well, it has a certain temperature, it has a color, it has a waxiness, it has a beautiful white wick, it has all these characteristics. But then if you light the candle and allow the candle to burn all the way down, you end up with something that's very different than what you started with, but it's still a candle, right? And so let's say that you let the candle burn all the way down and you have this molten, gooey mass. The wick is now, if there's any wick left, it's black and it's carbon, and it doesn't have the same color, it has none of the same shapes, but it's still a candle. So therefore, the idea there is that we must utilize our multiple senses simultaneously all the time. But at those moments, then, we have to understand the context of our observations. Another really important philosopher, and again, we're jumping through time here dramatically, is Tom Kuhn. He lived from 1922 to 1996. And Professor Kuhn was at Harvard and Berkeley and MIT and did a lot of very influential philosophical writings about science. But his most important and I think profound work was The Structure of Scientific Revolutions, which he published in 1962. And so this builds upon what we've been talking about so far, but it adds another important caveat, and that is that the nature of humanity, scientists are humans, and we bring to the table all the baggage that humans all have. One of the natures of science is that it's done by humans, and therefore change is almost universally resisted. And so what Kuhn puts forward is a look at the historical development of science and saying that some of the most important things we've ever had developed scientifically was a result of a lot of pain, a lot of struggle, and a lot of rejection by society. And so the scientific revolutions he talks about is the idea that people will methodically do scientific method or scientific inquiry, conduct research, have hypotheses tested, move forward with data, synthesize it, try to make predictions, try to put this into process models. But oftentimes the most important developments of this process is actually rejected by not only society but other scientists. And then eventually, if the scientific work that's being rejected or shunned at some level, if it's strong, solid science and based in reproducibility and prediction, it finally prevails.